These are solutions to September 1st evening slot physics paper. And the questions 1 to 5 are already discussed in another video in our channel. So right now we will discuss questions 6 to 20. So question 6, here we have 3 moles of monoatomic gas and they are following or undergoing an isobaric process. And they are asking us the ratio of delta U and delta W. So we know that delta U in any process is NCV delta T, and delta W in isobaric process particularly is NR delta T. And therefore, this ratio is nothing but CV by R. But CV is F by 2R, so this comes out to be F by 2. Monoatomic gas has 3 degrees of freedom, so this ratio comes out to be 1.5. And 1.5 is 15 by 10. So X is equal to 15. So the correct answer to this question is 15. I hope you are okay with this. Let us proceed on to question 7. An object of mass m is released from height h. So when it reaches ground, okay, we would expect the kinetic energy to be mgh, but the kinetic energy here is half m 0.8 root gh whole square. Okay, so which comes out to be 0.32 mgh, whereas the potential energy here is mgh. Okay, so as it comes down, all the mgh potential energy is lost. So work done by gravity is negative of change in potential energy, which is mgh. And work energy theorem tells us that work done by gravity plus work done by the air resistance shall be equal to change in kinetic energy. So work done by gravity is mgh and work done by air has to be found. That is equal to delta Ke, which is 0.32 mgh. So the work done by air comes out to be minus 0.68 mh into g, which is also 10. So it comes out to be minus 6.8 mh. So the correct answer is option A. I hope you are clear with this. Let's move on to the next question. And here there is a block of mass 5 kg, which is performing an oscillation. And the graph given, okay, for its potential energy, okay, is like y equal to 2.5 into x minus 2 whole square. In the exam, a graph is given. I am giving you the equation corresponding to that. Now we know that if potential energy versus x graph is given like this, where it is told to us that at x equal to 0 and 4, the potential energy is 10, and it is 0 at x equal to 2. So the potential energy U is equal to 2.5 into x minus 2 whole square. Now, what is the value of du by dx? Okay, that is 5 times x minus 2. This is easy to understand. So the force is 0 at x equal to 2, obviously, and therefore x equal to 2 is equilibrium location. Now from x equal to 2, if we move to 2 plus dx, then the force there will again be minus du by dx, as you know. So our Euler's expansion gives us that minus du by dx at x plus dx is equal to minus du by dx at any x minus d square u by dx square into dx by 1 factorial, and the remaining terms actually become 0. So anyway, du by dx at x equal to 2 is 0, so the first term becomes 0. So the force minus du by dx at 2 plus dx will straight away be minus d square u by dx square times dx, which is equal to, from the above, we can get d square u by dx square to be 5. So minus 5 dx. So what it means is, if the particle which is at 2, if it displaces by dx, it will experience a force towards this equilibrium location, and that force will be minus 5 dx. So acceleration will be minus 5 by m into the displacement, which is dx. Okay. So the mass is also 5 kg given. So it is minus 1 times the displacement dx. And therefore, omega square is equal to 1. And time period will be 2 pi by omega, which is 2 pi in this case. Okay. Because omega is also 1. Now, the given information is that time period of a pendulum of length 4 meters on this planet is same as that of the time period of our block. So the time period of the block performing SHM is 2 pi. And time period of simple pendulum will be 2 pi L upon G1, which is the acceleration due to gravity on this planet, which is equal to time period of our block, which is 2 pi. And therefore, L is equal to G1. So L is given as 4. So G1 will be 4 meter per second square. So it is L equal to G only in magnitudes. Dimension wise, it is not the same. So the acceleration due to gravity on this planet is 4 meter per second square. I hope you are clear with this. Now let us move on to the next question. So in this question, we can clearly see that there will be no current along one of the branches, which is in reverse bias. And in this branch, the current will be based on the total resistance, which is 30 and 130. And in this also, the diode will be like a resistor of 30 ohms. So the total resistance here is 160, here also is 160. And here there is no current flowing through this branch, and we can remove this as well. And therefore, the effective of these two will be 80 ohms. And this is already 20 ohms. So the total resistance is 100 ohms. So the total resistance is 100 ohms and voltage is 200 volts. And therefore, current will be 2 amperes. So the current through the cell will be 2 amperes. I hope you are clear with this. Now, let's move on to the next question. We have two particles projected at complementary angles. So one of them is projected at theta. The other one is projected at alpha, such that theta is equal to 90 minus alpha. range is u square sine 2 theta by g, and it is same for complementary angles, because this can also be written as u square by g into sine of 180 minus 2 theta, and that will be nothing but u square by g into sine 2 alpha. Okay, and therefore the range is same for both of them, and maximum height is u square sine square theta by 2g. Okay, that is h1, and h2 it will be u square sine square alpha by 2g. Since theta is less than alpha, automatically h1 will be less than h2. Okay, so option A is the correct answer. I hope you are clear with this. Then we have the 11th question. Here we are asked for the steady state current in this coil. At steady state, the inductors act as straight wires. There won't be any voltage difference across the inductor, and they do allow current. So we can say 3, 3, and these 3 are in parallel combination. Their effective resistance will be 1 ohm, and that will be in series with 2. So R total is 3 ohms, and therefore current will be 30 by 3, which is 10 amperes. So the correct answer is option B. I hope you are clear with this. Now we have the next question. A capacitor is connected to 20 volt battery and 10 ohm resistor, and the potential across the capacitor rises from 0 to 2 in 10 microseconds. We want the capacitance. So we know that in a simple capacitor which is initially uncharged, okay, if it is connected to a resistor and a battery, the charge on the capacitor at any time is CV times 1 minus e power minus t by RC. And therefore voltage across the capacitor at any time is the voltage, steady state voltage, which is battery voltage only here, e power minus t by RC. Now in this, let us substitute the capacitor voltage to be 2, and maximum voltage across battery will be 20. So 20 into 1 minus e to the power of minus, the time is 10 microseconds divided by RC. And therefore we get 1 by 10 is equal to 1 minus e power minus 10 divided by RC. Remember that 10 is in microseconds. So e to the power of minus 10 by RC is equal to 9 by 10, which implies 10 by RC, that is 10 microseconds by RC, is equal to ln of 10 by 9, which is 0.105. Now we want capacitance. So capacitance is equal to 10 microseconds divided by the resistance, which is 10 ohms, into 0.105. And therefore, since the denominator is close to 1.05 and the numerator is 10, we can say the capacitance is close to 9.5 microfarad. I hope you are clear with this. So here we are given a cylindrical container, and there is water in it. So let's place some water, and while the height of the container is given to be 17.5. An observer here observes the depth to be 17.5 by 2. So apparent depth is 17.5 divided by 2. This is equal to, if the actual depth is d divided by the refractive index of water, which is 4 by 3. So the actual depth is 17.5 divided by 2 into 4 divided by 3, which will come out to be 35 divided by 3. That will be close to 11.7. So the option is B, and I hope you are clear. Then we have this question, and here the loop is given to be moving with velocity v, and that velocity has to be found. And we know that across this, the motional EMF of VBL will be generated. Since the given resistor network has 9 ohms and the loop itself has 1 ohm, the total resistance is 10 ohms. So the current is given to be 200 milliamps. So current is equal to VBL divided by R. And we want the velocity of the loop. Velocity of the loop is equal to current, which is 200 into 10 to the power of minus 3, into resistance, which is 10, divided by B times L. B is 5 and length 20 centimeters is nothing but 0.2. And therefore, we will get the velocity to be 2 meters per second. So the correct option is option D. In the 15th question, we have accelerated the electron through 0.1 volts. So kinetic energy of such an electron will be nothing but 0.1 electron volts, 0.1 electron volts. And that is nothing but 0.1 into 1.6 into 10 to the power of minus 19 joules. Now kinetic energy of the nitrogen will be, because the total kinetic energy per molecule is given as F by 2 into Boltzmann constant into temperature. So here nitrogen, which is a diatomic gas, will have 5 degrees of freedom. So 5 by 2 into Boltzmann constant is 1.38 into 10 to the power of minus 23 into the temperature is given to be 300 Kelvin. So the ratio of the kinetic energy of electron to the kinetic energy of nitrogen here will be equal to 1.6 into 10 to the power of minus 20 joules divided by the other one is 2.5 into 1.38 into 300 into 10 to the power of minus 23. And this calculation comes close to 1.54. So the correct option is option A. We have 4 identical planets and they're revolving in a circle of radius r. So it is very easy to understand that they will be at the corners of a square which is inscribed inside this circle, and the diagonal of this square will be 2r, or the side of the square will be root 2 times r. So now speed of each of them is being asked. So we know that each mass is rotating in a circle of radius r. We can draw the circle also. One moment. So roughly we can think of this as a circle, and we know that the masses are m each. So consider any one of the masses. On that we have GMM divided by the distance is root 2r, so its square will be 2r square. The other one also will exert GMM divided by 2r square, and the other one will exert a force of GMM by 4r square. So upon resolution, we will realize that the net force towards center will be GMM by 4r square plus GMM by r square times root 2. So the net radial force is GM square by r square times 1 plus 4 root 2 divided by 4. And now we need to equate this to m v square divided by r. So the net force acting on this mass is equal to mass into necessary centripetal acceleration of this planet. So accordingly, V comes out to be under root of Gm by R times square root of 1 plus 4 root 2 divided by 4. However, there is no answer matching. Okay, so maybe the options given in the actual exam are little different, so don't worry about that. I'm sorry, I think I have made one mistake. Here, the force towards the center is GMM by r square into 1 by root 2 plus GMM by 4r square. And therefore, we will get this expression as root 2 plus 4 divided by 4 root 2. So the final expression also shall be changed. It is 4 plus square root 2 divided by 4 root 2. So I am confirming the answer to be the first option. Let us proceed. A rod hinged at the lower end is free to rotate, and the rod is initially given like this, and it is hinged at the lower end, and it is released from the position. When it again becomes vertical, it will be at the lower position like this. I hope you are clear with this. Now, it is clear that if the rod has length L, initially the center of mass is above by L by 2 distance. Finally, it is below the hinge by L by 2 distance. So the potential energy that is lowered, okay, potential energy lost, you can say that is mg into L. That is kinetic energy gained because there is no energy loss here. So finally, if the angular speed of the rod is omega, half into ml square by 3, which is its moment of inertia, into omega square. This is the kinetic energy gain. So equating the potential energy loss to the kinetic energy gain, we get L omega to be equal to 6GL under root. And since the free end is at a distance L from the center of rotation, it will have L omega as its speed. Now, length of the rod is not given. So I would say it is 6L into G. Based on the length given in the exam, the answer will differ. So here in a YDSE, as we know, both the slits will receive power from a single source. If their width is in the ratio 1:9, they receive power in the ratio 1:9. And therefore, if you think that on the screen, the first one will cause I1, second one will cause I2, I can confidently say I1 by I2 is equal to 1/9. Now, as we know, Imax by Imin on the screen, we have a standard formula, that is root I2 plus root I1 whole square divided by square root of I2 minus square root of I1 whole square. So this is nothing but square root of I2 by I1 plus 1 divided by square root of I2 minus I1 minus 1, the whole square. I2 by I1 under root is 3. So we will be getting 4 by 2 whole square, which is nothing but 4. So the answer to this question is 4. Sorry, but we are asked x. So x by 4 is 4. Okay, x by 4 is 4. And therefore, the answer to this question will be 16. The answer to this question will be 16. Next question. You have an inclined plane and you have a block, and we need to discuss about acceleration of the block relative to wedge. And the system is on a smooth horizontal plane as given to us. Now let us discuss this in detail. So since we know that the A relative of this wedge, block relative to wedge is like this, and by intuition we can easily feel that block moves this side. So let the acceleration of the block be A. So for the block, sorry, the acceleration of wedge is A. So acceleration of the block will have A relative tangential to the inclined plane and the acceleration of the wedge. And acceleration of the wedge will be simply A, as we have understood. Now let us draw the free body diagram of wedge and block separately. So for the wedge, it has normal reaction from the ground, which is vertically upwards. I will call it as N1, and its weight M2 into G. Oh, sorry, then let me call the normal reaction as N2. And the normal reaction by the block, okay, which is this way, it has a component this way and a component downwards. This component is N1 sine 37, and the vertical component will be N1 cos 37. So these will be the forces acting on the wedge. So I can confidently say N1 sine 37 is equal to M2 into its acceleration, which is A. The vertical forces cancel, but we are not really interested in them. Okay, that equation will bring a variable n2, so let us not write that. Now let us consider m2, but in the frame of the, consider the block in the frame of the wedge. In the frame of the wedge, apart from the normal reaction, that is N1, and its own gravitational force, that is M1g sine theta and M1g cos theta, the wedge will have a pseudo force of M1 into A in the forward direction, and its components tangential to the inclined plane will be M1A cos theta, and normal to the inclined plane would be M1A sine theta. And therefore, we know that along the normal direction relative to the inclined plane, the block is actually having zero acceleration. So we can equate N1 plus M1A sine theta to M1G cos theta. But from above, N1 is equal to M2A divided by sine theta or sine 37, and plus M1A sine theta, that is equal to M1G cos theta, and that will help us getting A. So A is equal to M1G cos theta. Let me substitute values. M1 is 8. So M1G is 80 into cos 37 is 4 by 5 divided by M2 by sine theta. M2 itself is 16 divided by sine theta is 3 by 5 plus M1 sine theta. M1 is 8 into sine theta is 3 by 5. Overall, the acceleration of the wedge alone comes out to be 64 divided by, this one is 80 by 3 plus 24 by 5. 80 by 3 plus 24 by 5. And that will be 472 upon 15. So 15 will go up. So this is the acceleration of the wedge. Now let us find out the A relative from the free body diagram I have drawn here. So simply M1 into A relative is equal to M1G sine theta plus M1A cos theta. So A relative is nothing but G sine theta, that is 10 times 3 by 5, which is nothing but 6 plus A cos theta, which we have got 64 into 15 divided by 472 into cos 37, which is 4 by 5. So this is 6 plus we have 64 into 12 divided by 472. So we can work it out. So this comes out to be 450 upon 59. So the correct option is option A. Let us proceed to question 20. So using logarithms and differentiation, we can easily get dy by y is equal to dg by g plus 3 times d alpha by alpha minus dA by A minus 3 d of d by d minus dB by d. But errors can be of any sign. So whenever we have minus sign here in error, we take the negative error, okay, accordingly that will get added up. So dg by g, okay, for percentages, let us multiply both sides with 100. So the percentage error in G, as they have given as 0.2, we have to write as it is, plus 3 times d alpha by alpha. So 3 times percentage error in alpha, which is 0.09, plus percentage error in A is 0.01, plus 3 times percentage error in D, that is 0.12, plus percentage error in B, which is 0.25. So in total, this is 0.3 plus, that is 0.42 plus 0.25. So 0.67%. So the correct option is option A. I hope you have understood all the solutions. Please subscribe to our channel, and we will update you with all the latest solutions of JEE mains papers and advanced papers, etc. Thank you so much for watching this video.